Hi folks, and welcome to this video about developing serverless applications with Kubernetes and Knative. My name's Sid, also known as DevOps Directive here on YouTube, and I'm a developer advocate working with Akamai to bring you this tutorial. Let's begin by discussing what serverless computing is. Wikipedia defines serverless computing as a cloud computing execution model in which the cloud provider executes resources on demand, taking care of servers on behalf of the customers. The key to serverless is simplifying how developers work with and configure infrastructure. Historically, most serverless offerings have been specific to certain cloud providers, but Knative gives us capabilities that run on top of Kubernetes so we can access serverless within a Kubernetes cluster. In today's video, I'll be showing you how to do just that with a managed Kubernetes cluster on Akamai Connected Cloud. There's a link in the description giving $100 credit to new customers so you can follow along. Without further ado, let's get started. Okay, we've got a lot to cover today, so I want to start by going over the plan for what we're going to cover in the video. In this intro portion, we're going to talk a little bit more about what serverless actually is, as well as a concept known as event-driven architecture, and its contrast to request-response-driven architecture. Thirdly, we're going to talk about the specific project, Knative, and some of the tooling that it has to allow us to accomplish serverless and event-driven architectures on Kubernetes. Then we're going to go through and set up our Kubernetes cluster on Akamai Connected Cloud. We're going to install the different Knative components, as well as installing our local command line interfaces to those components. Then we'll deploy one application using Knative functions, another application using Knative services, and then finally use these together in an event-driven application. Now, if that doesn't quite make sense yet, let's dive in and talk a little bit more about what these actually are. Serverless can mean a lot of different things to different people. And so specifically in the context of this video, I'm talking about serverless as meaning making it easier to deploy our applications and have to think less about the configuration of the servers where those are running. It might mean serverless functions where I'm just defining some chunk of code and then the system handles the rest of the setup and configuration around it. It might mean I'm still in control of a portion of my configuration, but I'm offloading some of that complexity onto the system. The next important concept is what's known as an event-driven architecture. The kind of default model for how applications work is known as a request-response architecture, in which I send a request to the application and it sends me back a response directly from that request. An event-driven architecture helps to decouple different services. And so in this model where we have lots of microservices, it can be useful rather than have each service call each other service directly to have what's known as an event-driven architecture, where instead of making a request directly to another service, I issue an event that goes to a common event bus, and any other service can listen to those events on the event bus and react to them. So rather than calling directly, I may issue an event. Another service can see that that event happened and take an action. This helps to decouple your architecture and allows you to potentially scale more easily. And now thirdly, what is Knative and how does it fit into this whole picture? Knative is a project within the Cloud Native Compute Foundation, which you install into a Kubernetes cluster, and it provides some serverless and event-driven architecture capabilities to developers who are using that cluster. I think this description is a good one. Knative is an automated system that helps development teams manage and maintain processes in Kubernetes. Its purpose is to simplify, automate, and monitor deployments so teams can spend less time on maintenance and more time on application development and projects. As we go through the different components and deploy our applications using Knative, we'll think about the alternative if we had used raw Kubernetes resources and how that would have played out. Now, I've already gone ahead and provisioned a Kubernetes cluster on Akamai, and I've downloaded the admin kubeconfig file here. So now I'm going to export my kubeconfig environment variable to point to that file. Use my present working directory / the name of the file. And now if I do kubectl get nodes, I can see the 3 nodes coming online for my new cluster. Now I'm going to go ahead and install the Knative components into the cluster. And it's important to think about the different job functions that would be interacting with these components. It's likely a infrastructure engineer who's sort of provisioning the clusters and installing these components. And then it's likely an application developer who is consuming these systems and using the Knative tooling to develop a web-based application. And so while it does simplify the usage of Kubernetes, there is some complex setup that we need to understand if we're going to operate and maintain a system like this. Knative serving is the portion of Knative used to define and deploy applications that will take requests and make responses. The equivalent of this in just raw Kubernetes would be something like a deployment and a service and an ingress. However, the Knative serving service is going to abstract that away such that we don't need to think about the details under the hood quite as much. When we install this into our cluster, we're going to have a number of custom resources that are created alongside the installation. And those are things like services, routes, configurations, and revisions. These are Knative specific concepts, and we'll talk through them a bit more as we end up using them. We're going to use this method of installing Knative using YAML files. So we're going to use a specific release from GitHub and install the resources based on that release. If we wanted to, we could confirm the image signatures here using a tool called Cosign. If you were doing this in production, I would certainly suggest that. Since this is just a demo, I'm going to install them without having verified. Then we're going to take this install command here. It's going to be a kubectl apply-f, and then it references a GitHub release from the Knative repo, specifically the serving CRD. So these are the custom resource definitions associated with Knative serving. I'll just copy this in. And as I already exported my kubeconfig, this is pointing to the right cluster. I'll paste it in. And we see many of those resources that I was just describing, those custom resources like services, routes, configurations, etc., being created within the cluster. This allows us to then use these new APIs within the Kubernetes cluster. Knative is a great example of what's known as the operator pattern, where there will be a system component and some extensions to the Kubernetes API. And we're able to use those new extensions to the API, and that controller running in our cluster will look for those new custom resources and act upon them when we create them. Now that we have the custom resources installed, we can then install the core components of Knative itself. So first, we're kind of defining those new APIs. Those are the custom resources. Now we can install the Knative serving components that will actually be running in the cluster based on the following command. Again, it's the same release within that same repo, but instead of the CRDs file, we're now adding the serving core file. As you can see, a whole bunch of different resources were just created. We started with a new namespace called Knative Serving. We're going to take a look at what's running there in a minute. We then set up some RBAC, some role-based access controls for the different components that are running and what they're able to access within the cluster. So that's these roles and cluster roles and service accounts. Because we had already applied these custom resources ahead of time, many of these you can see are unchanged. We've created some secrets containing information about how we're going to set up certificates if we wanted to manage TLS. It's added a number of config maps. And then here, it's created the actual controllers that are going to be running in the cluster. So let me do a k-get pods in the Knative serving namespace. And we can see it's created 4 different pods. Now, each of these components plays a critical role within the Knative serving system. The first of which, the activator. One really neat feature of Knative is the ability to scale your services down to 0 if they're receiving no traffic. And then when we receive a request, Knative will scale that back up to accept the request. So the activator serves as a buffer for those incoming messages. So if you're not running any copies of your application, the request needs to sit somewhere temporarily until you're able to get your application running. So the activator buffers that request and triggers the scale up from 0 to 1 of your application so you can access it. The auto scaling component, as the name implies, handles scaling of our application to 1 or more pods depending on the load that it is receiving, that the application is receiving. The controller is what is responsible for watching as we deploy new Knative resources into the cluster and managing the Kubernetes state associated with those. And then the webhook is used to validate incoming requests. As we create new Knative resources, it will take a look at those, at that incoming YAML and make sure that it is structured appropriately, make any tweaks, or issue errors if it's not correct. In addition to the core components of the Knative serving, we also need to install a networking layer for it to use for communication between our services. The default is Courier, so we're going to use that. And again, we're going to take a specific release of Courier and install that with the kubectl apply command. That gets installed into its own namespace, the Courier system namespace, along with the necessary components. And then I can update the config network config map in the Knative serving namespace to tell it to use Courier by default when we're creating new services. If I look in the courier system namespace and get the corresponding service, I can get an internal cluster IP as well as an external IP for a load balancer that was created. And so this is going off in the Akamai Connected Cloud and creating a node balancer so that I can send requests from the outside world to my cluster. Let's just take a look in the Knative serving namespace and make sure that all the pods look healthy. They do. In order to send requests, I could just use that IP address that was shown to me, but I can also set up DNS to make it a little nicer. At this point, we have Knative serving installed into the cluster, and I'm going to install the Knative CLI onto my laptop. There's a variety of different installation instructions here on the knative.dev website. Because I'm on a Mac, I'll use Homebrew. You would just do brew install knative/client/kn. As you can see, I've already got the Knative CLI installed. Similarly, there's a specific command line just for the functions component, which is a subset of the serving components that I'll install here. It's in a separate tap. So you do brew tap, Knative extensions, Knative plugins, and then brew install func. Once again, I've installed it ahead of time. And so now I have the Knative CLI as well as the function CLI available in my command line. One final piece of additional setup is to create a container image repository. In this case, I'm using the GitHub container registry. You could also use Docker Hub. I've created this package here that will be used to store our container images, because even though it's serverless and we only have to define our application code, behind the scenes, Knative is going to build a container image, push it to a container registry, and then Kubernetes is going to use that container when it creates our application. So even though some of this is abstracted away from us, we still need to have access to a container registry that we can push and pull from. So I've created this package within my GitHub and then created a personal access token here with access to the repo as well as write permission for the packages. This will allow Knative to, on my behalf, push to that container image repo on GitHub. I'll copy that token and export it as GitHub token. Now we are ready to start using Knative serving to define our applications. We're going to start using the functions capability. So this is the method where we only really need to define our application and not worry about a Docker file, not worry about a lot of the networking configuration, etc. I've created this make file that's going to have all of the commands that I need to generate the necessary code. And let's just follow along and I'll talk through what's happening. I'm setting this function name environment variable here at the top. It's going to get used across a number of the different make targets. If you're on a Unix-based system, it likely has make installed. And to call one of these make targets, first, I'm going to navigate to the functions directory. And then I can just run make create function. And it will execute the command here on line 4, the func command line, create language, Python, and then the function name. All of these different languages are supported by the function CLI. Node.js, Python, Go, Quarkus, Rust, Spring Boot, and TypeScript. The examples I'm using in this video are going to all be in Python, just because I think it's very easy to read and understand what's going on. But if you have a different language you'd like to use, you're welcome to go ahead and use that. Now, what did this create function command actually do? As we can see, a new subdirectory has appeared within my directory. It's created a number of things. We've got a func.py, that's going to be the main Python file where our application lives. We've got a requirements.txt file. And so if we had any third-party dependencies, we could add them to this requirements.txt file, and Knative should just pull those in at build time, and it should just work. It's set up some testing for us, so that's nice if we want to add unit tests to our code. And then we have a git ignore file to prevent unwanted files from getting into Git. And then we have a func ignore file that tells the function CLI which files should not be tracked in the image build. Let's take a look within our func.py and see what exists in there. Now, the first thing you'll notice is that it's using a tool, it's using a package called Parliament. And Parliament is essentially a framework that handles the routing, liveness, readiness, endpoints, and cloud event extraction. So it handles a lot of the sort of nuts and bolts of how you should take an incoming request to your function and get the request data out of it. And it works with Flask to do that. The default setup has created a couple of functions for us, the first of which is called payload print, which effectively just takes in a request and dumps out the contents of that request in a slightly different fashion, depending on whether it's a post or a get and the type of data within the request itself. The next function is called pretty print. It just takes in a request and prints it nicely to the console. And then at the bottom, we have our main function. And this is where our actual application logic is going to live. In this case, we're not doing anything very fancy. We're taking in a request. If it has a payload, we will print it out. If not, we will just print empty request. And so this is the application that's going to be running and listening for requests in Knative. Now we want to be able to execute this code locally without needing to go through all of the process of building a container image, etc. And so for that, we're going to need to set up our local Python environment. So I'm going to use pyenv to select the specific version of Python that I want to use, in this case 3.11.4. I'm then going to create a virtual environment within my first function directory. So do python -m venv./venv. This creates a virtual environment directory. And then I'll source the file that was created there to actually activate my virtual environment. At this point, with my virtual environment activated, I can install the dependencies from my requirements.txt file by doing pip install -r requirements.txt. You'll notice that I have these change directory commands here at the front. This is because my makefile lives outside of the my first function directory. So do make install dependencies. Now it went off, saw this dependency, installed it, along with all of its transitive dependencies. With my dependencies installed, I can now run my app locally by executing this app.shell function. As you can see, using sh, it invokes Python using the Parliament module in this directory. So I can do make run func local. The application should now be listening on port 8080, and I can do make curl app, which will send a curl request to localhost 8080 with the message hello. And as you can see, on the left-hand side, my application printed to console that it received this request. It was a GET request, and it contained the query string message hello. So that shows us how we can execute our code locally. We need to install the dependencies, and then we need to execute the app.sh shell script from our local system. In order to execute the tests, we'll do something similar. We'll invoke Python and then pass it the name of our test func.py. So I can do make run test local. It goes through, it receives an empty request because that's all that happens in the test functions. It passes an empty dictionary to the main function and then confirms that it got an empty function out and that it was a code 200, meaning success. We can add more tests here, obviously, as we include our own business logic, but this is nice to have this default test harness set up and easily executable. The base image that is used when Knative goes off and builds the container image is stored in GitHub Container Registry. And so we need to authenticate our local Docker system with that Knative registry. To do that, we're going to use the docker login command and pass it the name of the GitHub Container Registry for Knative. So to make auth knative GHCR. In this case, I'm going to use my username, Sid Palace, and pass it that GitHub token that I created earlier from within the GitHub UI. Authentication succeeded. Great. Now, when I go to build my function, it will be able to download the base image that's required. I've also set up this variable containing the name of the GitHub Container Registry repo that I'm using to store my container image that's built by Knative. That will get used in a number of the following commands where we build and execute our function. To build the function locally, we can issue the func build and pass it the name of a registry. As I mentioned, you need to be authenticated to that registry already. The first time you're building an image in this way, it can take a little while because it has to pull that base image from the Knative registry. It needs to download all the dependencies because your cache won't have anything in it. And so future builds should be faster, but this first one can take a while. Okay, as you can see, it finally finished building and we now have a new image and it has tagged the image using the latest tag. Now I can execute this image locally before I ever use Knative to run it on the cluster. To do that, we can use the func CLI with the run command. And again, we pass it the name of our registry. So I'll do make run image local. it detected that our function was up to date with the latest build, and it's running it on port 8080. So once again, I can do make curl. It sends that same request, and we get it inside of our application, running inside of the container on our local system. Great. At this point, we have our basic application running. We've executed it locally. We've executed it locally inside of a container. Let's go ahead and deploy it to our cluster. This is going to use the function deploy command. And again, we're going to pass it the name of that registry so that it knows which image to use. I've added this echo command here just to remind myself that I needed to authenticate to GitHub because I was building my image locally, but I didn't actually need to push that to GitHub Container Registry. So I'll do make deploy. It's using that personal access token that I authenticated with earlier. Depending on your internet speeds, this may be quick or it may take a while. Now that it is pushed to that remote registry, it's deploying the function to the cluster. Well, it will reference that image and Kubernetes will pull it in to run the application. Because we didn't specify namespace, it's deployed into the default namespace. It's providing us a URL to the internal DNS of the function itself. Now we also want to configure DNS so that we'll be able to access our application from outside the cluster. There is a pretty cool method. You can use a service called slip.io. It allows us to get a public domain very easily without any real setup. However, I want to map this to an actual domain name that I own. So I'll click the real DNS option here. And I need to use that external IP address that our courier service provided and set it up with a wildcard domain for star.knative on my domain, devopsdirective.com. So I'll go over to Cloudflare and set that up. Click add record. It's an A type. It'll be star.knative. And I'm going to turn off proxying because I don't want Cloudflare taking these requests and handling TLS or anything like that. I want to send them directly to the load balancer for the cluster. With that, I'll click save. Now that my function is deployed into the cluster, there's a few different ways that I can invoke it. The first of which is to invoke it via the CLI. So I can use this function invoke command, make invoke. We're just going to execute func invoke. That will send this hello world message to my cluster. I also can access it via DNS, and I'm going to get the domain name by describing my service. So I'll use the Knative CLI, service describe, and then the name of my service is my first function. We can see it prints out some useful information here. It tells us that the latest revision is receiving 100% of traffic. It's using the image that I referenced earlier from GitHub Container Registry, and specifically this hash. Looks like it's okay. And it gives us this URL here. Now, in order for it to use my knative.devopsdirective.com URL, I did need to make one tweak here, and that is to apply this patch to the config domain in the Knative serving namespace. And so let's take a look at that config map. That config map within it has a data object, and then within the data object, I have my specific domain, and then an empty string says that this domain should be used for all services that Knative is managing. If you have multiple domains, you would set up selectors within here to point one domain to certain services and another domain to others. But in this case, this is just a catch-all, and knative.devopsdirective.com will be used for all of my different services. Like I said, we can now take this URL and access it from within a browser. And we get back this empty response. I can also pass query parameters in the URL, and those will get displayed because that's what my function is defined to do. Now, if I do get pods in the default namespace, we can see that I have a single pod and it's of status running. I mentioned earlier this concept of scaling to 0. So if I don't send any requests to my service for a period of time, eventually this will turn to terminating and then disappear entirely. I can do watch kubectl get pods, and now it's in terminating status, and eventually it will go away. I believe the default is for if you have a lack of traffic for 1 minute, it will then terminate the pod. And this allows us to have many, many functions within a cluster, and they don't all need to be consuming resources at once. They can be in this scaled to 0 state. Only the functions which are being actively used will scale up and use resources. Now there's 0 pods within my namespace. Let me refresh over here and we'll see the pod come online right away. pending, running, and we got our response back. So there is a bit of a cold start time associated with that pod coming online and being started, but it allows you to have that scaled to zero effect if you're trying to minimize the resources being used. You can also turn that feature off and keep your minimum number of pods for a given service at 1, and that would eliminate that cold start time and allow you to have your application respond quicker, even in the case when it hadn't been used in a while. Now we looked at the output of that Knative service describe call. Let's also look at the output of the Knative revisions list call. And here we have a single revision from when we deployed the function for the first time. It's receiving 100% of traffic, and it's in a ready state. Let me make a slight change to my application, redeploy it, and we'll see an additional revision in this listing. I'll go here to func.py. I'll add an exclamation point, save it, make deploy. Hopefully this time, because we built it once, the building process should be much quicker. There we go. We've built the image. Now we're pushing it. The image is pushed. We're deploying to the cluster. Now let's list the revisions once again. And we see our original function as well as our additional revision quadruple O2. The latest version, that number 2, is receiving 100% of the traffic. And the first version is just kept around. So if we wanted to roll back to it or split the traffic between the two, we could do so. Now finally, the other thing that function sets up behind the scene in addition to the service and the revisions are the routes. So we can describe those routes. And the routes are the networking aspect of our function. We see a reference to our service, it gives us the URL, and it gives us the traffic targets of which of our function revisions we're going to send traffic to. And so that gives us an understanding of the Knative functions capability, where all we really need to do is define our func.py, including our main function. We're able to specify dependencies in the requirements.txt, and then Knative handles the rest of it, including building our image, pushing it to that container registry, setting up all of the necessary Kubernetes resources and routing and networking, and deploying that into the cluster. The next thing we're going to move on to is still within the Knative serving system, but instead of using functions, this will be the case where, let's say we need a little bit more control over what goes into the container image. Maybe we're calling some third-party binary that needs to exist that wouldn't get built in using the function approach. And so here we're going to have our own container image, and we're going to define the service directly. I'll go into this O2 serving. Again, I've got a makefile here with a number of commands crafted to enable us to use the Knative command line to create these services and modify them. And so the first thing that I'm going to do is to use this third-party public image called Podinfo. So if you're not familiar with it, it is an application from Stefan Prodan that is used to highlight a number of different Kubernetes features. So it provides a great public image that we can use to demonstrate the various features of a system like this. I'll use the service create command. I'm naming the service Podinfo, passing it a reference to the container image repository, telling it which port it should be listening on. The application will already be listening on this, and this will tell Knative how to serve traffic to it properly. And then we're going to pass it this Podinfo UI color. So this is an environment variable that is unique to this application, which will set the background color of the application when we actually access it. So if I do, I'll navigate to that O2 serving directory, then I'll do make deploy Podinfo service blue. And the reason I'm calling it blue is that I'm going to highlight traffic splitting in a blue-green deployment where we start with one application, we bring it up. That's going to be the blue copy. We then bring up another version of our application, the green copy, and then we'll route traffic across them to show how a blue-green deploy might work. Okay, it looks like my service is now available. I can go to this URL, and we can see our application is deployed here. And that background color that I used is the same as the default background color, which is this nice blue color. Let's update the service with a different environment variable. For that, I can use the Knative CLI, the service update command, passing it a reference to the name of the service. Again, everything else is the same, except I'm changing this environment variable color to a different one. Okay, that new copy of the service has been deployed, and Knative has routed traffic from the old one to the new one. It should be on the same domain name. And so here, if I go back to my browser and refresh, we can see it's already highlighting this light green instead of the blue that it was before. Once again, I'll list the revisions. We can see my functions from before, as well as my two services that I've created directly via the Knative CLI. To show you some of the networking control that we can use, I'm going to change the service such that half of the traffic is being sent to my original Podinfo service and half of the traffic is being sent to my new one. This would allow us to do any sort of things like roll out a service proportionally to a new set of users, test and make sure it's working properly before we roll it out to all of our user base. To do this, I can once again use the Knative CLI, the service update command, but now I'll pass it the traffic option and reference my latest is going to be Podinfo quadruple 02, as well as the original Podinfo service, and each of those is going to get 50% of the traffic. So I'll do make apply traffic split. And now if I go back and refresh the page, we see it's blue, green, and every time I refresh, it's going to potentially switch because half of the requests are going to end up on the blue one, half of the requests are going to end up on the green one. And so if you were using a canary deployment or a blue-green deployment method, this shows you how you can split traffic between two versions that are active within the cluster. And Knative abstracts so much of the complexity of setting something like this up, such that all we had to do was deploy our two versions and specify a traffic split. All of the complex networking that happens behind the scenes is handled by Knative. We use the Knative CLI to create those with the create and the update commands and various flags. This is what the YAML version of that would look like. So this is the specific Knative service object. It's in that default namespace with the name that we gave it. We're specifying the image. We're setting some environment variables and the port. And then here's that traffic split configuration where we're going to specify half the traffic goes to Podinfo number 1 and half the traffic goes to Podinfo number 2. I just wanted to connect the dots such that when we create something with the KN CLI, behind the scenes, that's generating some YAML that's going to be applied to the cluster as these custom resources. Knative then monitors for these custom resources and updates the Kubernetes state accordingly to run our application. So this gives you now a sense of what we can do if we need a little bit more control over how things are being served. We can use these service objects directly and modify the various routes and configurations. And so knowing how the functions capability works for simple things, but then knowing how to dive in and work with the services directly when you need a bit more control can be really powerful as you build out these types of serverless applications. Next up, we're going to install the Knative eventing components. And the process is quite similar to how we installed Knative serving. Once again, you could verify the image signatures if you wanted to. I'm going to first install these CRDs. This creates all those custom resources in the cluster. Then I'll install the core components from the eventing system. All of these resources are going to live in the Knative eventing namespace. Again, we start by setting up some role-based access control, some configuration, the eventing controller itself, and some webhook configurations to ensure that when we create these types of resources, they are valid. Let's look at the pods in that namespace. Looks like the two pods have come online properly. Now there's two additional optional things that we can install in our Knative eventing setup. The first of which is a channel layer. So channel allows us to set up messaging directly from sources and sync. So sources being the service that issues an event and a sync being the source that consumes an event. You can use Apache Kafka. You can use this in-memory standalone channel, which is simple, but does not retain the events in a durable fashion. So it would not be suitable for a production use case, or you can use the NATS channel option. I'm going to use this in-memory option just as an easy way to get started. We can install that with that command. And then we can also install a broker layer, and a broker provides a higher level abstraction over a lot of the same concepts. So how we pass and deliver these messages from and between services. Again, Kafka is one option for the backend. RabbitMQ is another. I'm going to use the simpler MT channel-based implementation. And so this is going to use the channels under the hood to set up event routing. And so it should provide us a simple way to get started. With those two things in place, we'll now be able to create a broker resource. We use these system components to set up how those messages will get routed from sources to syncs within the cluster. With all of that installation and setup out of the way, I thought it would be useful to draw a little diagram of the application that I'm going to be building. These are services. So the first one is going to be a Knative function that I'm going to create called myEventFunction. Then I'm going to set up a trigger such that it's listening for specific events that contain a particular metadata. When one of those events is issued into the cluster, myEventFunction will receive that event, process it, and actually return a new event that gets passed back to the broker. And then I have a second service that I'm going to create, which is set up with a trigger waiting for events that match its particular metadata. And I'm going to configure things such that the event created by my first function matches the one listened for by my second service. And then I'll be able to show sort of triggering my first event, watching that event process, having it issue a new cloud event, which then triggers my second event, which highlights this sort of passing of information in a decoupled fashion. Rather than have myEventFunction call event display directly, it passes it via this broker. Now, why might you want to do this? I've talked about this decoupling nature. Let's say you have some event that happens within your system, and there needs to be many different services that respond to that event. I don't know, let's say it's a new commit was just pushed to your GitHub repo, and you want to have a variety of services process information about that. You could have GitHub call each of your services independently. You could also have GitHub call one service and then have that service fan out those calls to all of the sub-services. Or you could have a single event, which is created by GitHub, and have many services that are listening for events that match that particular type. And so that's the approach that's used here, is that third one. And it allows us to, one, decouple, and two, scale our services in this fashion. So the first thing that I'm going to do is similar to what we did in the first part of the video, where we use the Knative functions CLI to create a new Python function. I'll navigate to my O3 directory, and I'll do make create function. As we can see, my event function is now created here. Then I'm going to change the func.py for one that I've written ahead of time, and I'll walk through what it's doing. So this will contain the main function of the application itself. You'll see we're still using Parliament here. However, we've modified the defaults a bit. We've got our main function, and in this function, we're going to do a few things. One, we're going to say, hey, we've gotten a request, and we're going to log out the data associated with that request. That'll allow us to see specifically the request that came in. Then I'm going to construct a response, and this response needs to have a very specific format. There's a standard called Cloud Events, which specifies how we should create these types of events, and it is this structure that Knative uses for this type of eventing. Now, specifically, each of these events should have a set of metadata associated with them. We're going to add each of these HTTP headers to our response such that the eventing system will appropriately use them. The first of which is an ID, and so I'm going to generate a UUID here. That'll be a string of characters that will make this request unique within the system. I'm specifying which version of Cloud Events the spec is following. I'm specifying a source and a type, and it is these two attributes that other services are going to use to listen for this specific type of event so that they will know when to respond to it. I then return that response from my main function, and that will get added as an event on the event bus within our cluster. I have a different GitHub container registry repository set up for this function, and so that is specified in this variable, and I'll do make deploy to both build my function, push it to the container image registry, and deploy a copy of it into the cluster as a Knative service. And with that, we can see that it has built and pushed, and we have a URL here that we can access. We've got our response. As you can see, that response is hard-coded in the app itself, so that's what we expected. Hi from Knative event-driven app. And so while our service can respond directly to a request like we just showed from the browser, we can also now set up a trigger within our Knative eventing system that will trigger it without calling it directly. And so that's what we'll do now. The first thing we're going to do is set up a broker in our default namespace, and it's going to use that empty channel-based broker that I deployed a bit earlier. So I can do make deploy broker. It looks like that broker is now up and healthy, so we'll be able to use it. Now with the broker defined, the next thing that we'll need to define is the trigger. So the trigger uses that references that broker and tells Knative specifically what types of events my service cares about. We can see within the definition here, we're specifying two attributes, the type and the source, like we specified in our application itself. These are going to come in as HTTP headers. Knative will watch for these specific attributes on an event. And when both of these two things are matched, it will send it to my subscriber, that is my event function, the service. So I'll deploy this one. And again, when I call make deploy trigger, it's really behind the scenes calling kubectl apply-f and the trigger.yaml file. I just applied it, so it's unchanged. So at this point, we have the broker deployed, we have our trigger one deployed, and my event function deployed. Now we need to create an event that matches the type and source such that trigger one will be triggered. And so my broker is not listening on a public DNS name. So in order to issue an event to it, I need to create a pod in my cluster and call that broker's internal DNS name. In order to do that, I'll run this kubectl run curl command. That will create a pod in the cluster using this busybox curl image, giving me an interactive shell using the binary @bin/sh. Okay, now this prompt is running inside of that container, inside of that pod on the cluster. And I want to use this curl command to create an event that matches the type and source that I specified in my trigger. Now, if I do kubectl get pods, I only have one pod running in my default namespace. That's the curl pod that I created and I'm accessing here on the left-hand terminal. If I then watch that command and issue this curl request specifying the type and source that match those from my trigger, it should create that event, and then the broker should see the trigger and pass it, spinning up a copy of my function to execute on it. Paste that in, hit return. And as we can see on the right, Knative detects that event properly, sends it to my application, and spins up a pod to process it. Now let's create the final piece of the puzzle, the second service, which is going to respond from the event created from my first function. Now I'm going to use the knative service create command and use this public image called event display. And this is just an image that makes it very easy to see the incoming cloud events. And so I know that it's listening on port 880, so I'll pass that in as well, which tells Knative to set up routing such that traffic will go on port 880 to that application. In order for this new service to react to the event from my first service, I need to create a trigger. Before we used a YAML file, this is how we can use the Knative CLI to do the same thing. In this case, we're creating a trigger. We're naming it event display. We're using that default broker that we set up before. We're passing it the type and source that it should be listening for. And then we're specifying the sync. This is which service should receive that event if it matches those filters. So I can do this command. And now we have a trigger wired up to send events coming from my other function to this service. Once again, let's set this up to watch, and we see my original service is scaling back down because we haven't had any requests to it. I'm going to create a curl pod again within the cluster. We can see that container coming online. And now I'm going to issue my curl command. And what do I expect to happen? One, the curl command is going to get caught by the first trigger, but not the second because of the type and source specified in my filters. So the curl command is going to get caught by trigger one and spin up my event function to process it. It's going to respond with a new cloud event, and that cloud event happens to match the filters on trigger two. So then the event display service will be triggered and it will process that. So we should see my event function come online, then event display function come online. We'll take a look at the logs to see what they're printing out. Let me paste that in, hit return. Cool, so we see my event function 001 coming online, it responds, and so then event display comes online slightly afterwards. Let's look at the logs. We can see the cloud event that came from my application message, "Hi from Knative event-driven app." Remember, that was the message sent in my cloud event from my application. And so we've completed that path of creating an event, having one application consume it, responding with a different event, having another application consume that. And so that hopefully gives you this idea that we can create and pass messages in a decoupled fashion using an event-driven architecture with Knative eventing. Now, before we close out the video, let's take a look back at what we've covered today, because it was a lot. We started by talking about what serverless computing is and what event-driven architecture is, how those two things play together. Then specifically, what is Knative and how does it allow us to utilize these two techniques within a Kubernetes cluster? We installed the various Knative components into our cluster, and we installed the Knative CLIs onto our local system. We then explored three different portions of Knative. The first was Knative functions, and that's the portion of Knative that allows you to deploy services without having to configure very much. You can just create the application code that you care about, and it handles a lot of the configuration around it of building and pushing container images, setting up the various Kubernetes resources, setting up networking so that we can get access to those functions from outside the cluster, etc. Next, we looked at Knative services, which give us a little bit more control over the configuration of our application than a function does. However, it still abstracts away a lot of the things that you would have needed to do if you were setting this up manually on a Kubernetes cluster. We also showed how to traffic split between two active versions of a service, which unlocks a number of different deployment techniques from canary deployments to blue-green deployments, etc. And then we dove into the event-driven application portion of Knative eventing. We created an event. The first application responded to it, replied with a different event that was caught by the second application, and highlighted how event-driven applications allow us to decouple our application architecture and how Knative eventing simplifies the process of setting all that up. We also looked specifically at cloud events, which is the event standard that is used by Knative eventing, and how we use the type and source fields to filter on specific event types for any given service. Hopefully you now feel ready to go off and leverage Knative within your own systems. Like I said, there's going to be some setup time, but once you have it set up and configured, it should hopefully streamline application development for Kubernetes within your setup. If you're interested in learning more about Kubernetes and developing for the Akamai Connected Cloud, check out the other videos on this YouTube channel. There's a number of technical tutorials from myself as well as other developer advocates that will give you a great foundation for building out applications in a cloud-native way. That's it for today. Take care.